Now let us discuss about the necessity of multi-staging system, multi-staging in refrigeration system. So here I have drawn a pH chart of multi-compression and multi-evaporator system. A vapor refrigerant, dry saturated vapor refrigerant, enters to the low pressure compressor at state 1 and it is compressed to state 2. So process 1 to 2 is a low pressure compression process. In this process, enthalpy increases due to the compression. At the outlet of the compression, the high pressure and high temperature vapor will come out. This high temperature and high pressure refrigerant is cooled to dry saturated refrigerant corresponding to the pressure of state 2. So 2 to 3 process, we can call it as intercooling process. And after intercooling, dry saturated vapor at the intermediate pressure is available. That dry saturated vapor is then compressed in HP compressor, that is a high pressure compressor, from state 3 to state 4. So in short, rather than compressing the vapor refrigerant from state 1 to state 4 in a single stage, it is compressed in a double stage. Then you may ask, what is the advantage? If I will compress it in a single stage, then the compression process, it will follow this path. It will follow this path. And then at state 4 dash, the compressed refrigerant will come out. That indicates that in a single stage, if the refrigerant is compressed, then the process 1 to 4 dash will be followed. But if it is compressed in 2 stages, then it will be followed 1 to 2, 2 to 3, 3 to 4. What is the advantage? Advantage is that there is a saving in work done. If it is a compressed in a single stage, then 1 to 4 dash process will be followed. And this process, it consumes more work done. Because if it is compressed in a single stage, then work done will be H4 dash minus H1. If it is compressed in a 2 stages, then the compressor work will be H1 minus H4. H4 minus H1. H4 dash minus H1 is more than the H4 minus H1. So it clearly indicates that if compression process is done in a 2 stages instead of 1 stage, there is a saving in work done. So there is a less consumption of electrical energy. It indicates. So then what will be the pressure ratio so that we can adopt multi-stage compression? If the pressure ratio, that means condenser pressure, ratio of condenser pressure to evaporator pressure. If it is more than 4 to 5, then instead of using a single stage compression, always a multi-stage compression is preferred. So this is advantage. So that means there is a saving in this much work done. This much area, it is reduced on pH chart due to the multi-staging. So it indicates there is a saving in a work done. Then at 4, the refrigerant at high pressure it will come out and high temperature. This high temperature refrigerant, it is cooled in the condenser from 4 to 5. And at 5, it enters into the expansion device. Expansion process, it is isenthalpic process. That is, enthalpy remains constant. So in this case also, instead of expanding in a single stage, if we will expand it in a double stages, that means 2 expansion valves are used, then the net cooling effect will increase. Let us see how it increases. See, if I would have expanded the high pressure liquid refrigerant from 5 to evaporator pressure in a single stage, then I would have followed this path. So this I will name it as, say, 8 dash. If single stage expansion is carried, then the process 5 to 8 dash will be followed. So in this case, the net effect, that is a net cooling effect, will be H1 minus H8 dash. However, if I will follow instead of single stage, double stage, then the path 5 to 6, then 6 to 7 is again cooling, intermediate cooling, and then 7 to 8 expansion in the second stage. So this is a first stage expansion and this is a second stage expansion. So if expansion is carried out in 2 stages, then the state 8 will be achieved at the end of expansion. In the 2-stage expansion, the net effect, that is a net cooling effect, will be H1 minus H8. So in this case, from this, it is very much clear that H1 minus H8 is this much. And H1 minus H8, here it is this much. So it indicates that H1 minus H8 is less than, H1 minus H8 dash is less than H1 minus H8. That means if a single stage expansion is followed, then the net refrigerating effect, it reduces. And these are the reasons that instead of following a simple refrigeration cycle in a single stage compression, we should follow a multi-stage compression and a multi-evaporator system for more coefficient of performance. So this is a necessity of multi-stage compression instead of single stage compression. Thank you.